Welcome. In this comprehensive guide, we'll explore how to effectively use Cloud Run with relational databases like Cloud SQL to build scalable and reliable applications. Cloud Run is Google Cloud's serverless platform for running containerized applications. It automatically scales your applications from zero to thousands of instances based on incoming requests, and you only pay for the compute time you actually use. The key advantage is that Cloud Run is completely serverless. You don't need to manage servers, worry about capacity planning, or handle infrastructure maintenance. Relational databases store structured data with defined relationships between tables. They provide ACID compliance for data reliability and support complex SQL queries. Cloud SQL is Google's managed service for MySQL, PostgreSQL, and SQL Server databases. Cloud SQL handles database administration tasks like backups, patches, and high availability, allowing you to focus on your application logic rather than database management. When you combine Cloud Run with Cloud SQL, you get a powerful architecture for building scalable web applications. Your containerized application runs on Cloud Run and connects securely to your managed database on Cloud SQL. Throughout this series, we'll dive deep into best practices for connecting Cloud Run to Cloud SQL. We'll cover secure connections, scaling challenges, connection pooling, monitoring, and real-world implementation examples to help you build robust applications. Our main goal is to help you build applications that are scalable, secure, and reliable by leveraging the power of Cloud Run and Cloud SQL together effectively. Cloud SQL is Google Cloud's fully managed relational database service. This means Google takes care of all the complex operational tasks, so you don't have to worry about them. Cloud SQL supports three popular database engines that developers use every day. You can choose MySQL for web applications, PostgreSQL for complex queries and data analysis, or SQL Server for Microsoft-based environments. The key benefit of Cloud SQL is that it's fully managed. Google handles all the operational tasks that would normally consume your time and resources. This includes automatic patching, regular backups, and database replication for high availability. This is what we call Database as a Service, or DBaaS. Instead of installing and maintaining database software on your own servers, you simply use Cloud SQL as a service. It's like having a database expert team managing your database infrastructure 24/7. In summary, Cloud SQL is your database solution that just works. It supports the databases you already know, handles all the complex operational tasks automatically, and lets you focus on building great applications instead of managing database infrastructure. Using Cloud SQL with Cloud Run brings several powerful benefits that simplify how you build and manage applications. Let's explore these key advantages that make this combination so effective for modern development. The integration between Cloud Run and Cloud SQL creates a seamless connection where your containerized applications can easily access managed database services. First, Cloud SQL dramatically simplifies data persistence. Instead of worrying about database setup, configuration, and maintenance, your Cloud Run applications can immediately start storing and retrieving data with just a few lines of code. Second, Cloud SQL provides automated database management. Google takes care of security patches, automated backups, performance optimization, and maintenance tasks that would normally require dedicated database administrators. Third, this integration dramatically reduces operational overhead. Instead of managing servers, installing databases, configuring security, and setting up monitoring, you can focus entirely on building your application while Google handles all the infrastructure complexity. Fourth, Cloud SQL dramatically improves development speed. Traditional database setup can take days or weeks, but with Cloud SQL, you can have a production-ready database running in minutes, allowing developers to start building features immediately. Finally, Cloud SQL scales seamlessly with your Cloud Run applications. As your application grows and handles more traffic, Cloud SQL can automatically adjust resources, ensuring your database performance matches your application's needs without manual intervention. The combination of Cloud SQL with Cloud Run creates a powerful development environment where you can focus on building great applications instead of managing infrastructure. This integration delivers faster development cycles, reduced operational complexity, and automatic scaling, everything you need for modern application development. When deciding between Cloud SQL and self-managed databases, you're essentially choosing between convenience and control. Let's explore what each option involves and why many developers are making the switch to Cloud SQL. Let's compare these two approaches side by side. On the left, we have self-managed databases, where you handle everything yourself. On the right, we have Cloud SQL, where Google manages the infrastructure for you. With self-managed databases, you're responsible for everything. You need to set up and configure servers, manually apply patches and updates, manage backups, monitor performance around the clock, handle security, and manually scale resources as needed. Cloud SQL handles all of these tasks automatically. It provides automated setup, automatic patching, automated backups, built-in monitoring, managed security, and automatic scaling. This is what we mean when we say Cloud SQL handles the heavy lifting. Now let's understand the fundamental trade-off you're making when choosing between these approaches. This is the fundamental trade-off. Self-managed databases give you more control over every aspect of your database, but require significant operational overhead. Cloud SQL reduces that overhead dramatically, but you give up some control in exchange. Let's look at some specific examples of what this means in practice. Here's what this trade-off means in practice. Database administration tasks that typically take over 20 hours per week are reduced to just 2 hours. You get a 99.95% uptime SLA with automatic failover. Most importantly, your developers can focus on building application features instead of managing database infrastructure. The key takeaway is that Cloud SQL is ideal when you want to reduce operational overhead and focus on your application. Choose self-managed databases only when you need specific configurations or have unique requirements that Cloud SQL cannot accommodate. The Cloud SQL proxy is a crucial security component that acts as an intermediary between your Cloud services and Cloud SQL databases. Think of it as a secure tunnel that handles all the complex security details for you. Here we have a Cloud service that needs to connect to a Cloud SQL database. Without the proxy, this connection would require complex security configurations. The Cloud SQL proxy sits between your application and database, acting as a secure intermediary. It handles all the security complexity so your application doesn't have to. The proxy establishes encrypted SSL/TLS connections on both sides. This means all data traveling between your Cloud service and Cloud SQL database is fully encrypted and secure. Now let's look at how authentication works with the Cloud SQL proxy. Authentication happens through Cloud IAM in 4 simple steps. First, your Cloud service authenticates with Cloud IAM using its service account. Second, IAM verifies that the service account has the necessary permissions to connect to the specific Cloud SQL instance. Third, once authenticated, the proxy establishes the secure encrypted connection to your Cloud SQL database. Finally, your application gets a ready-to-use database connection without having to handle any of the security complexity. The Cloud SQL proxy provides several key security benefits that make database connections much simpler and more secure. First, the proxy eliminates manual certificate management. You don't need to worry about SSL certificates, renewals, or configuration. The proxy handles all of this automatically. Second, there's no need for IP address whitelisting. Traditional database connections require you to whitelist specific IP addresses, but the proxy uses IAM authentication instead, which is much more flexible and secure. Third, you get enhanced security and compliance. The proxy provides end-to-end encryption combined with Google Cloud's IAM system, giving you enterprise-grade security without the complexity. These 3 benefits make the Cloud SQL proxy an essential component for any production Cloud application that needs to connect to Cloud SQL databases securely and reliably. In summary, the Cloud SQL proxy simplifies database security by providing encrypted connections, IAM-based authentication, and automatic certificate management, all while eliminating the need for complex network configurations. When connecting Cloud to Cloud SQL, you have 2 main options: using the Cloud SQL proxy or making direct connections. Understanding the differences between these approaches is crucial for building secure and maintainable applications. Let's compare these 2 approaches side by side. On the left, we have direct connections, and on the right, the Cloud SQL proxy method. Direct connections require several manual steps. First, you must manage SSL certificates to ensure encrypted communication. Then you need to whitelist IP addresses, which can be challenging with Cloud Run's dynamic IPs. The entire process involves manual configuration and is often error-prone. In contrast, the Cloud SQL proxy automates all these security tasks. It handles SSL certificates automatically, eliminates the need for IP whitelisting, provides simple configuration, and is secure by default. This makes it the recommended approach for most applications. Now let's examine the key benefits that make the Cloud SQL proxy the preferred choice for most developers and organizations. First, enhanced security. The proxy provides automatic encryption and authentication without requiring you to manually manage SSL certificates or worry about certificate rotation. Second, simplified management. You don't need to worry about IP whitelisting or complex network configurations. The proxy handles all the networking complexity behind the scenes. Finally, reduced configuration errors. By automating the setup process, the proxy significantly reduces the chance of human error and improves overall system reliability. This makes it the clear choice for production environments. In summary, while direct connections are possible, the Cloud SQL proxy is the recommended approach due to its superior security, ease of use, and reduced maintenance overhead. It's the best practice for connecting Cloud Run applications to Cloud SQL databases. Unix domain sockets are a fundamental concept for understanding how Cloud Run securely connects to Cloud SQL. Think of them as a special type of communication channel that works entirely within a single machine. A Unix domain socket is essentially a file-based mechanism that allows different processes running on the same machine to communicate with each other. Unlike network sockets that use IP addresses and ports, Unix sockets use the file system. Here's how it works. Instead of using network protocols, processes communicate through a special file in the file system. Process A writes to the socket file, and process B reads from it. This all happens locally on the same machine. In Cloud Run, when you use the Add Cloud SQL Instances flag, Google automatically creates a special socket file in your container. This file appears at the path /cloudsql/ followed by your project, region, and instance name. This socket file is the key to secure communication. Your application connects to this file path instead of using an IP address and port. The Cloud SQL proxy handles all the authentication and encryption behind the scenes. Let's compare Unix sockets with traditional IP connections. Unix sockets are file-based and work only on the same machine, with no IP address required and automatic authentication. IP connections are network-based, can connect to remote machines, but require explicit IP addresses, ports, and manual authentication setup. Unix sockets provide several key benefits for Cloud Run and Cloud SQL connections. They offer enhanced security since there's no network exposure, better performance without network overhead, simplified configuration with no IP management needed, and automatic authentication that's built right into the Cloud SQL proxy. Understanding Unix domain sockets helps you appreciate why Cloud Run's integration with Cloud SQL is both secure and efficient. The socket-based approach eliminates many of the complexities and security concerns associated with traditional database connections. Resource contention is one of the most common performance challenges in database systems. When multiple database transactions try to access the same shared resource at the same time, conflicts arise that can significantly slow down your application. Resource contention occurs when multiple database transactions attempt to access the same shared resource simultaneously. Think of it like multiple people trying to use the same parking spot at the same time. Let's look at a practical example. Here we have a user account table in our database. Each row represents a user account with their balance information. Now imagine 3 different transactions all trying to access the same user account at the exact same time. Transaction 1 wants to withdraw money, Transaction 2 wants to deposit money, and Transaction 3 wants to check the balance. When this happens, the database system must lock the resource to prevent data corruption. Only one transaction can access the row at a time, while the others must wait in line. The performance impact of resource contention can be dramatic. A query that normally takes 50 milliseconds might take 500 milliseconds or more when waiting for locks to be released. This leads to increased response times, reduced overall throughput, and ultimately a poor user experience. The database system spends more time managing conflicts than actually processing useful work. Understanding resource contention is crucial for database optimization. It helps you design better schemas, optimize query patterns, choose appropriate isolation levels, and plan for proper scaling as your application grows. Cloudrun's max instances parameter is a powerful tool for controlling database load. By limiting the number of container instances, you can prevent your database from being overwhelmed by too many concurrent connections. Without limits, Cloudrun can scale to many container instances during traffic spikes. Each container creates database connections, potentially overwhelming your Cloud SQL instance with too many concurrent connections. The solution is to use the max instances parameter. This gcloud command limits the maximum number of container instances that Cloudrun will create for your service. With max instances set to 3, Cloudrun will never create more than 3 container instances, regardless of traffic volume. This ensures your database receives a manageable number of connections. Here's a practical comparison. Without limits, you might get 20 or more instances creating 200 plus database connections, leading to overload. With max instances set to 5, you get exactly 5 instances with about 50 connections, keeping your database stable. Key takeaways. Max instances controls container scaling. Fewer containers mean fewer database connections. This prevents database overload during traffic spikes, and you should set the limit based on your database capacity. Remember this command format to set your max instances limit and protect your database from connection overload. Internal connection pools are a crucial mechanism for managing database connections efficiently in applications. They help control concurrency and prevent database overload. An internal connection pool is a mechanism within an application that maintains a set of persistent connections to the database server. Instead of creating new connections for each request, applications borrow existing connections, use them, and then return them to the pool. Here we can see the structure of a connection pool. The pool maintains multiple persistent connections to the database server. Each connection in the pool is ready to be used by the application when needed. Now let's see how the borrow, use, and return cycle works. When an application needs to execute a database query, it follows a specific process. Step 1. The application requests a connection from the pool. The pool manager checks for available connections and assigns one to the requesting application. Step 2. The borrowed connection is used to execute the database query. During this time, the connection is marked as active and cannot be used by other parts of the application. Step 3. After the query completes, the connection is returned to the pool and becomes available for other requests. This cycle repeats for every database operation. Connection pools are essential for managing concurrency. Without a pool, applications might create unlimited connections, potentially overwhelming the database. With a pool, the number of simultaneous connections is controlled and limited. Internal connection pools provide several key benefits. They limit simultaneous database connections, prevent database overload, improve application performance, and effectively manage transaction concurrency. This makes them essential for scalable applications. When internal connection pools aren't enough to handle your database load, it's time to consider external connection pooling. This is where tools like pgbouncer become essential for managing database connections efficiently. Let's first understand the problem. When you have high connection churn, meaning connections are frequently created and destroyed, or when multiple applications need to share database connections, internal pools may not be sufficient. pgbouncer solves this by acting as a middleware layer between your applications and the database. It multiplexes many application connections onto a smaller, more manageable set of database connections. Here's how pgbouncer works in practice. It maintains a pool of persistent connections to your database. When applications need to query the database, pgbouncer assigns them an available connection from the pool, executes the query, and then returns the connection to the pool for reuse. The key benefits of using PG Bouncer include reduced connection overhead, better resource utilization, and the ability to handle connection spikes without overwhelming your database. It's particularly valuable when you have multiple applications or microservices that need to share database access efficiently. Remember, external connection pools like PG Bouncer are most effective when internal connection pools alone cannot handle your application's database load. They're essential for high-traffic applications with multiple services or when you experience frequent connection churn that impacts database performance. High availability in Cloud SQL is a critical feature that ensures your database remains accessible even when problems occur. Think of it as having a backup plan that automatically kicks in when needed. Cloud SQL High Availability works by creating two database instances in different zones within the same region. This geographic separation protects against zone-level failures while keeping latency low. When the primary instance becomes unresponsive, Cloud SQL automatically detects this failure and promotes the secondary instance to become the new primary. This process typically takes about 1 minute. While high availability significantly reduces downtime, applications still need to be designed for resilience. They should handle short disconnections gracefully and implement proper retry mechanisms. To summarize, high availability in Cloud SQL provides automatic failover protection with minimal downtime, but your applications should still be designed to handle brief interruptions gracefully. This combination gives you the best of both worlds: automated protection and resilient applications. Even though Cloud SQL is a managed service, monitoring your database instances is absolutely crucial for maintaining optimal performance and preventing issues before they impact your applications. Google manages the infrastructure, but you still need to monitor key performance metrics to ensure your database runs smoothly and efficiently. There are 3 critical metrics you should always monitor for your Cloud SQL instances. Let's examine each one and understand what they tell us about database performance. CPU usage shows how much processing power your database is consuming. Sustained high CPU usage above 80% can indicate query performance issues or insufficient resources. Memory usage indicates how efficiently your database is caching data. High memory usage isn't always bad, but sudden spikes or consistently low cache hit rates can signal problems. Disk input-output operations show how much your database is reading from and writing to storage. High disk I/O can indicate slow queries or insufficient indexing. Understanding how to identify bottlenecks is crucial for maintaining optimal database performance. Let's look at common warning signs and what they indicate. When you see these warning signs, there are several solutions you can implement. Scale up your instance size for more resources, optimize slow queries, add read replicas to distribute load, or implement connection pooling. Proactive monitoring means setting up alerts that notify you before problems become critical. Here are the essential alerts every Cloud SQL instance should have. Set up alerts for CPU usage above 80%, memory usage above 90%, low disk space, high connection counts, and replication lag. These alerts help you respond quickly to potential issues. Remember these key points. Continuously monitor your critical metrics, set up proactive alerts, identify bottlenecks early, and use monitoring data to make informed optimization decisions. Effective monitoring is essential for maintaining reliable database performance. Cloud SQL's automatic storage increase feature is a powerful tool that can significantly reduce database maintenance overhead and alert fatigue. When this feature is enabled, Cloud SQL automatically monitors your database storage usage and expands capacity when needed, without any manual intervention. As your database grows and approaches capacity limits, the automatic storage increase feature kicks in seamlessly. One of the key benefits of enabling automatic storage increase is that you can safely disable monitoring alerts related to disk space getting full. However, it's crucial to understand that while you can disable immediate disk space alerts, monitoring overall storage usage trends remains important for cost management and capacity planning. To summarize, automatic storage, Increase reduces alert fatigue and manual intervention, but smart monitoring of storage trends ensures optimal database performance and cost control. When connecting Cloud Run to Cloud SQL, security is a critical consideration. The Cloud SQL proxy and direct connections handle security very differently, and understanding these differences is essential for making the right choice. Let's compare these two approaches side by side. On the left, we have the Cloud SQL proxy method, and on the right, direct connections to Cloud SQL. The Cloud SQL proxy provides several key security advantages. First, it automatically encrypts all data in transit, ensuring your database communications are protected without any additional configuration. Second, it uses Cloud IAM for authentication, which means you can leverage Google Cloud's robust identity and access management system instead of managing database credentials manually. This combination significantly reduces the risk of unauthorized access, as the proxy handles all the complex security protocols automatically. Direct connections, on the other hand, require you to manually manage SSL certificates. This includes generating, distributing, and regularly rotating certificates to maintain security. If certificate management is not handled correctly, it can become a significant security vulnerability. Expired certificates, improper storage, or weak certificate policies can all compromise your database security. Additionally, setting up secure direct connections requires more complex configuration, including proper firewall rules, IP whitelisting, and SSL configuration, which increases the chance of misconfiguration. Here are the key security takeaways when choosing between Cloud SQL proxy and direct connections. The Cloud SQL proxy automatically handles encryption and uses Cloud IAM for authentication, making it much more secure by default. Direct connections require you to manage certificates manually, which can introduce security risks if not done properly. The proxy significantly reduces both security vulnerabilities and configuration complexity, making it easier to maintain secure connections. For production workloads, the Cloud SQL proxy is strongly recommended due to its superior security features and ease of management. Cloud Run is designed to automatically scale your applications based on incoming traffic. When traffic is low, you might have just one instance running. But when traffic suddenly increases, Cloud Run can scale up rapidly, creating multiple instances within seconds to handle the load. This rapid scaling capability is powerful, but it creates a significant challenge for your database. Each Cloud Run instance needs to connect to your Cloud SQL database to read and write data. When Cloud Run scales from one instance to 10 instances in seconds, your database suddenly receives 10 times more connection requests and database queries. This sudden surge can overwhelm the database, causing it to slow down or even become unresponsive. Let me show you the specific problems this creates. When a database becomes overwhelmed, you see dramatic performance degradation. Response times can increase from 50 milliseconds to over 2 seconds, and connection errors start occurring. The solution is to limit database concurrency, controlling how many connections and transactions can happen simultaneously. By implementing connection pools and limiting concurrent database operations, you can ensure your database remains stable and responsive even when Cloud Run scales rapidly. When working with Cloud Run and databases, we need control mechanisms to prevent overwhelming our database with too many connections. There are two primary approaches we can use. The first mechanism is setting a scaling boundary using the max instances parameter. This directly limits how many Cloud Run instances can be created. The second mechanism uses connection pools to manage the number of active database connections. The scaling boundary works by setting a maximum number of Cloud Run instances that can run simultaneously. Here we see 5 potential application instances, but with max instances set to 3, only the first 3 can be active. Each active instance creates connections to the database. By limiting instances to 3, we automatically limit the maximum number of potential database connections, preventing database overload. Connection pools work differently. Instead of limiting instances, they manage the actual database connections. Applications connect to the pool, which maintains a controlled number of connections to the database. Here we see 3 applications connecting to the pool, but the pool only maintains 2 active database connections. This prevents the database from being overwhelmed, even if we have many application instances running. Both mechanisms have their advantages. Scaling boundaries are simple to implement, but may limit your application's ability to scale. Connection pools provide more precise control and allow more instances to run, but require additional configuration. The best practice is often to use both mechanisms together. Set a reasonable max instances limit and implement connection pooling for optimal database performance and application scalability. Setting up a MySQL Cloud SQL instance is straightforward using the Google Cloud CLI. We'll walk through the essential command and configuration options step by step. The foundation of creating a Cloud SQL instance is gcloud SQL instances create command. This command requires an instance name and several important parameters. 3 essential parameters are required. Database version specifies which MySQL version to use. Region determines where your instance will be hosted. And tier defines the machine type and resources. Important configuration options include setting backup times, enabling binary logging for replication, and allowing automatic storage increases to prevent running out of space. Here's a complete example that creates a MySQL instance named my-MySQL instance with all the recommended settings. This command sets up automatic backups, enables binary logging, and allows storage to grow automatically. After creating the instance, you must set a root password using the gcloud SQL user's set password command. Always use a strong, unique password in production environments. Key takeaways for setting up MySQL Cloud SQL. Always specify your database version and region, enable automatic backups and storage increases for reliability, set a strong root password immediately after creation, and choose the appropriate machine tier for your workload requirements. Once your Cloud SQL instance is created, the next crucial step is initializing your database schema. This means setting up the structure of your database by creating tables, defining relationships, and establishing the foundation for your application's data. The first step is connecting to your Cloud SQL instance using the gcloud command line tool. The gcloud SQL connect command provides a secure way to access your database directly from your terminal. Now that you're connected, you can create your database tables. Let's start with a simple example, creating a users table with essential fields like ID, name, email, and timestamps. Database relationships are crucial for organizing your data efficiently. Let's create a second table for user posts and establish a foreign key relationship between users and their posts. Visual representation helps understand the relationship structure. Here we can see how the users table connects to the posts table through the user ID foreign key, creating a one-to-many relationship. Here are the key takeaways for initializing your database schema. Always use gcloud SQL Connect for secure connections. Plan your table structure before creating them. Define relationships with foreign keys for data integrity, and consider using migration scripts for version control of your schema changes. Security is absolutely critical when working with Cloud SQL instances. A poorly secured database can expose sensitive data and create serious vulnerabilities in your application. The first and most important rule: never use the default root user for your application connections. The root user has unlimited privileges and poses a massive security risk. Here's why the root user is dangerous. It has full administrative privileges, can drop entire databases, offers no granular access control, and makes security auditing nearly impossible. Instead, create dedicated users for each application. Here's how you create a user with limited privileges. Notice we only grant the specific permissions the application needs. Here's a clear comparison. The root user has unlimited access to everything, while a dedicated application user only has the specific permissions needed for the application to function. Network security is equally important. Configure authorized networks to limit which IP addresses can connect. Use private IPs when possible, enable SSL encryption, and implement VPC peering for network isolation. The Cloud SQL proxy provides an additional security layer. It automatically handles SSL encryption, uses IAM-based authentication, eliminates certificate management, and creates secure connection tunnels. Here are the key security practices to remember. Never use the root user, create dedicated users with minimal privileges, configure network restrictions, always use the Cloud SQL proxy, and enable SSL encryption. Following these practices will significantly improve your database security. The Cloud SQL Proxy %% host restriction is a powerful security feature that controls exactly how applications can connect to your Cloud SQL database. This host restriction pattern tells Cloud SQL to only accept connections that come through the Cloud SQL proxy. The %% acts as a wildcard that matches any proxy connection. Let me show you how this restriction works in practice. Here we have a Cloud SQL instance, the Cloud SQL proxy, and an application attempting a direct connection. When an application tries to connect directly to the database, the Cloud SQL proxy host restriction blocks this connection immediately. The database will not accept any connection that doesn't come through the proxy. However, connections that come through the Cloud SQL proxy are allowed because they match the Cloud SQL proxy host pattern. The proxy authenticates and encrypts these connections before forwarding them to the database. This host restriction provides 3 key security benefits. First, all connections must be authenticated through the proxy. Second, all traffic is encrypted in transit. And third, it prevents any unauthorized direct access to your database. The key takeaway is that Cloud SQL Proxy %% creates a secure gateway pattern. It ensures that only authenticated and encrypted proxy connections can reach your database while blocking all direct connection attempts. YourSurprise.eu is a large-scale e-commerce platform that faces significant database performance challenges during peak shopping periods. They needed a systematic approach to manage their Cloud SQL database performance. YourSurprise.eu carefully monitors 3 critical metrics to understand their database performance. They track transaction rate to see how many queries per second their database handles, monitor concurrency to understand active connections, and watch vCPU usage to gauge processing capacity. Through careful monitoring, YourSurprise.eu discovered there's an optimal transaction concurrency level. Too few concurrent transactions underutilize the database, while too many cause contention and reduce performance. They found the sweet spot where performance peaks. When YourSurprise.eu detects peak demand periods with high transaction rates and increased concurrency, they proactively scale their database resources. They maintain their optimal concurrency level while adding more processing capacity to handle the increased load. YourSurprise.eu's approach has been highly successful. By monitoring key metrics, finding their optimal transaction concurrency, and scaling proactively, they maintain excellent performance during peak periods while preventing database overload and optimizing resource utilization. We've covered a lot of ground in this series about CloudRun and Cloud SQL. Now let's consolidate everything into key takeaways and best practices that will help you build scalable and reliable applications. First and most importantly, always use Cloud SQL Proxy for secure connections. This provides encrypted connections, automatic authentication, and eliminates the need to manage IP allow lists or SSL certificates. Second, control database concurrency carefully. Use max instances to limit CloudRun scaling and implement connection pooling both internally in your application and externally with tools like pgBouncer to prevent overwhelming your database. Third, implement comprehensive monitoring. Set up alerts for CPU usage, memory consumption, connection counts, and enable automatic storage increases. Proactive monitoring prevents performance issues before they impact users. Fourth, secure your database instances properly. Restrict host access using patterns like Cloud SQL Proxy %, create dedicated database users for each application, and never use root accounts in production environments. By following these 4 best practices, using Cloud SQL Proxy for security, controlling concurrency with max instances and connection pools, implementing comprehensive monitoring, and securing access properly, you can build scalable and reliable applications with CloudRun and Cloud SQL. Thank you for watching this comprehensive series on CloudRun and Cloud SQL. Apply these practices in your projects, and you'll be well on your way to building robust, scalable applications in the cloud.